Oh, it was loud. We want to evaluate the following. So this is some sort of generic denominator, x squared minus a squared. Okay. Recall that x squared minus a squared can be factors. A is x minus a times x plus a. So what we are looking, first of all, this is a proper rational fraction because we have 1 over x squared minus a squared. And we're going to factor it as 1 over x minus a times x plus a. And in terms of partial fraction decomposition, we decompose it as a1 over x minus a plus a2 over x plus a. And I'm going to multiply by the least common denominator as I did before. And at this point, we lose the denominator on both sides. And on the left we have simply 1, and on the right we have a1 times x plus a plus a2 times x minus a. And this is very conducive to use the technique that I just showed you before. For instance, if we let x equal a, we're going to lose the a2 terms. So if x equals a, then on the left we still have 1, and on the right we have simply 2a times a1. So right away we get a1 equals 1 over 2a, like so. And if we choose x equals negative a, we're going to lose the a1 term. And we have 1 on the left, and here we have negative 2a times a2. So a2 equals negative 1 over 2a. So at this point we can write our integral. So the integral of dx over x squared minus a squared is now, we have 1 over 2a is a common factor, so I can factor it outside the integral, and what we have left is 1 over x minus a minus 1 over x plus a dx. So we have 1 over 2a, and here we have the natural log of x minus a minus the natural log of x plus a plus c. And the final answer, the final result will be 1 over 2a. We can simplify the difference between the difference of natural logs, so it will be natural log of a quotient, x minus a over x plus a plus c, like so. Notice that this applies to an integral where you have a difference of 2 squares in the denominator. Okay? So this is an important result that we can use as part of a solution in the future. So we don't have to reinvent the wheel. We don't have to reinvent or re-solve this problem. So let me write a comment here. This is an important result that can be used as a part of future solutions. It means that we can add it to the catalog of integrals. Similar case, remember when we solved the integral of the secant? That wasn't a trivial integral, and the result was the natural log of the secant plus the tangent. right? The absolute natural log of the absolute value of the secant plus the tangent. So every time now we have a component where we have to integrate the secant, we're not going to redo everything. We know already the result. Same here. For example, if we need to solve something like this, the integral of 2x plus, let's say, 3 over x plus or minus 4 over x squared minus 144 dx, like so. All right, so the first two items are very simple, but in the third one we can use this result. So let's see, what is the solution here? Integrate 2x, get simply x squared. Integrate 3 over x, well, that will be 3 times the natural log of x, right? Integrate this one, so we have negative 4 times, I'm looking here, 1 over 2a, well, a is 12, right? So it will be 4 times 1 over 24. And now I have the natural log of x minus 12 over x plus 12 plus c. So just simplify it one more time. Get x squared plus 3 natural log of x plus, or minus rather, 1/6 natural log of x minus 12 over x plus 12 plus c. Okay? Make sense? Sometimes it will be hidden. For instance, I just talked to my previous student at the end of the previous class, the 8 o'clock class. So I gave them this example. I said, what happens if you need to integrate dx over, let's say, 2x plus 2x squared plus 10, right? I'm sorry, minus 10. Apologize. Okay, so here's what we're going to do. I'm going to factor out the 1/2. So I have now the integral of 1/2 dx over x squared minus 5. Now, even though this is not a difference of 2 squared, I can arrange it such that it would be 1/2 integral of dx over x squared minus the square root of 5 squared, like so. You see what I did? So now I'm going to apply, I can apply it to this result. That's why I said it's a very important result, what we have here, because I can write it as 1/2 times what? 1 over 2a. Well, a is square root of 5, so times 1 over 2 square root of 5, and natural log of the absolute value of x minus square root of 5 divided by x plus square root of 5 plus c. Again, reduce this here and get 1 over 4 square root of 5 times the natural log of x minus square root of 5 over x plus square root of 5 plus c.